Hello, welcome to the second class, the second lecture in the Introduction to Semantics. Today we're going to get started looking at a little bit how to do semantics. In particular, we're going to look at semantics as science. What does it mean to be a science? Well, a science is a way of looking at some way that the world is. Could be physics, could be chemistry, could be language. And in this case, we're looking at meaning. To be a science is to be aiming to get the truth, and you generally use a particular way of doing that. It involves four things. Observation, you find out how things look like they work. Okay. Then you have to give an explanation, and your explanation is a theory. Theories generally are wrong, but hopefully they're not so terribly wrong. They can do some of the work you want them to. And when you find out how they're wrong, you can fix them. The way we fix them, the way we find out what they're wrong, whether they're wrong, is by the predictions that they make. If a theory doesn't make a prediction, it's not a theory. If it does make a prediction, it's got a possibility of being wrong. And you find that out by testing. You look at the predictions, you see what the theory predicts, you make new observations, and you see, do the observations match the prediction? Okay, if so, you have support for the theory. Do the observations go against the prediction? Well, then you know your theory is wrong and you have to do something new to change it. So we're going to be making observations largely about meaning. And there are two kinds of observations that are particularly important. Observations involving entailment. Entailment is a relation between two sentences. One sentence, S1, entails another sentence, S2, just in case the truth of the second one follows from the truth of the first one. And we'll see examples soon. Another observation that we make is an observation of contradiction. A sentence S1 will contradict a sentence S2, just in case it's impossible for both of those sentences to be true together. Examples of entailment: the sentence Ed came and Lou left entails Ed came. Why? Oh, because if you know that Ed came and Lou left, it follows that Ed came. Everybody knows that intuitively. Okay. And entailment is one of the things we're going to want our semantic theory to explain for us. Other relations are different. Ed came does not entail that Ed came and Lou left. Okay, if Lou didn't leave, then the second one would be false, but Ed came could still be true. Ed came and Lou left does not entail that Lou does not like Ed. Okay, maybe she doesn't. Maybe she left because she doesn't, but that's not an entailment. We can't know that that's true just from the first sentence by itself. We would have to have a lot more knowledge to know that that's the case. And finally, a fairly obvious one, Ed came does not entail that Ed did not come. When we look at contradiction, we get a slightly different pattern. Ed came does contradict Ed did not come. It's not possible for both of those sentences to be true at the same time. Ed came and Lou left, that doesn't contradict Ed came. We say that those two sentences are compatible. It's possible for them both to be true. We don't know as a fact that they will both be true. Maybe Ed didn't actually come, in which case they're both false. Maybe Ed came, but Lou didn't leave. Then the second sentence is true and the first sentence is false, but they're possibly both true together. Ed came does not contradict Ed came and Lou left. This is just the symmetrical version. Contradiction doesn't care about order. Entailment did. Ed came and Lou left does not contradict Lou does not like Ed. It's possible for those two to both be true. You don't know that they're going to both be true just because one of them is. But you also don't know that one is going to be false because the other one is true. Okay, so that's our basic observation. And now we want to start coming up with an analysis. Our analysis will take a couple of, be in two parts. The first part is giving a more formal definition of entailment that will fit with what we know about meaning. From the last chapter, for the first lecture, we had a way of describing meanings of sentences as having a sense and as having a denotation, okay? And so we want an analysis of entailment that's going to fit in with those notions of meaning. So here we go. A sentence S1 entails a sentence S2 just in case there are no worlds W such that the intension of S1 contains the pair W true and the intention of S2 contains the pair W false. Okay, this is a reminder, the intention of a sentence is a set of pairs of the form W, comma, TV, where W is a world and TV is a truth value, either true or false. For example, if S is true at world W sub I, then its intention will include W sub I, comma, true. And if S is false at world W sub J, its intention will include the pair W sub J, false. S1 entails S2 then, just in case their intentions contain at most the first three patterns, A, B, and C, but not pattern D. For any world that you pick, there are four possibilities of the combinations of truth and falsity for S1 and S2. If S1 entails S2, it can contain the first pattern. The intention of S1 is true at that world, and the intention of S2 is true at that world. It can contain the second pattern. The intention of S1 is false at that world, and the intention of S2 is true at that world. They contain the pattern in the pattern C. The intention of S1 is false at the world, and the intention of S2 is also false at that world. But it cannot contain pattern D. Pattern D is where the intention of S1 is true at the world, but the intention of S2 is false at the world, okay? Now we can think of this as patterns for particular worlds, but the intention will, of course, contain many, 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 many worlds to look at. We just want to make sure that all of the patterns for all of the worlds that you choose fit into pattern A, B, and C, not D. If so, then S1 would entail S2. We can do the same thing with contradiction. We can give an analysis more in terms of the formal idea of meaning that we looked at in chapter 1. S1 contradicts S2 just in case there are no worlds W such that the intentions of S1 and S2 both contain the pair W true. If we ask what that means in terms of the actual intentions, we say S1 contradicts S2 just in case their intentions contain at most patterns B, C, and D, but not pattern A. I've kept the labels of the patterns the same as before, but I've changed the ordering here. So pattern B has the intention of S1 false at W, the intention of S2 true at W. Okay. Pattern C has both intentions false at W. Pattern D has S1 true at W, S2 false at W. All of those are fine. Sentences that contradict each other can still be, one of them can be true, or maybe they're both false. But they can't both be true. You can't have the pattern in A, where the intention of S1 is true at world W, and the intention of S2 is also true at world W. Now, this isn't so much a theory as a description. It doesn't actually make predictions yet. It describes entailment and contradiction, and it describes them in terms that are terms that will be useful, that we can relate to the denotations of sentences. But in order to make predictions, we have to add something more. We have to add a semantics. And in particular, what we're going to do in this lecture is add an analysis of and, or, if, and not. Before we turn to the analysis of those, we have to turn first to logic to see how logic is going to be used. Logic is the formal basis for semantics. Logic is, if you will, the tools for doing semantics. Natural language, like English, it can be ambiguous and imprecise. Sometimes one sentence can have multiple meanings. Sometimes it's unclear whether it's true of a certain situation because it's vague. What we do to help clarify what we're asking is to give interpretations in a language that's not ambiguous and that's very precise. And we're going to use those interpretations to ask whether we can do what we want to with meaning. We can describe the meanings we want to describe by making use of those logical interpretations. Okay, so to show what different interpretations a natural language sentence can have, we're going to look first at propositional logic. Propositional logic is a logic that looks at things at a fairly high level. It takes the pieces to be individual propositions. A proposition is the meaning of a declarative sentence, of a sentence that can be used to make a statement. And you get a sense for what a proposition is by looking at examples. Sometimes you have two sentences that, at least possibly, denote the same proposition. John saw Mary, and Mary was seen by John. Yes, there are differences between those two. I'm not sure what those differences are, but they seem to also be saying the same thing. They're going to be true in the same situations. They're going to be false in the same situations. So for us, we're going to take that to mean that these are two sentences that have the same proposition as their meaning. We can also have one sentence that has two associated with two propositions. This is ambiguity. A standard example is visiting relatives can be boring. That sentence can be saying one of two different things. It can be talking about those people who are relatives who visit and say that they can be boring people. Or it can say that the activity of going to visit relatives can be a boring thing to do. Okay. If we want to describe those two meanings, well, one way of doing that is to translate them into logic, into different, and give them different logical translations. Okay, so with that as a background, we're going to look at English expressions that combine with sentences. The ones we're looking at, we're going to analyze them as logical operators that combine with propositions. Okay, and it's important to keep a distinction between the sentences of English and the analysis of logic. English is what we're trying to understand. We have intuitions about English. We have a sense for what words mean, what sentences mean, how sentences are connected. The logical translations are what we're going to use as a way of trying to get a better understanding of what those meanings are, or what they could possibly be, okay? So we're looking at words and, or, if, and not, and in very simple kinds of sentences. And is also called conjunction, and it gives us sentences like John came and Mary left. Or is often called disjunction, and gives us sentences like John came or Mary left. If gives us a conditional. If John came, Mary left. And all of these can be seen as combining two sentences. They combine the sentence John came and the sentence Mary left. The word not doesn't, strictly speaking in English, combine with a sentence. It combines instead with a predicate. Not combines here with come. That then combines with did, and then combines with John. But it behaves in many ways as if it connects with a sentence. In particular, in terms of its meaning, it seems to behave like it connects with a sentence. And so we're going to treat it here together with the other words that very obviously connect sentences. And we're going to look at these words one at a time. We're going to treat them as their meaning as an open question, but we're going to give a very specific proposal, which is a common proposal made in the literature. Then we're going to test those proposals and see how well do they do. We won't give a complete test, but we'll get at least an idea of how to do such a test and how to maybe defend the proposal. So conjunction first. We're going to make the proposal that the English word and is analyzed as logical conjunction, represented as an ampersand, and I'll just read that as logical and. Logical and joins two propositions together to create a new complex proposition. Okay? So if we have P and Q as two propositions, logical conjunction creates from them the new proposition P and Q. The interpretation of logical and can be described entirely in terms of truth values. And this is one of the things that makes it very useful. If both P and Q are true, then the formula P and Q is also true. If P is false and or if Q is false, then P and Q is false. This interpretation for logical and can be represented in a truth table. Here, each line represents one way things could possibly be. Okay, so if P is true, Q is true, P and Q is true. First line here. Second line, if P is true and Q is false, then P and Q is false. P is false, Q is true, then P and Q is false. P is false and Q is false, P and Q is false. So now we have an analysis in place, and now we can look to try to test, challenge that analysis and see if it holds up. So what challenges do we have for analyzing English and as logical and? Well, the first one is that logical and, as we defined it, only connects propositions. English and, however, can connect other expressions. So up above, we have John saw Mary and Bill. English and connecting two names, Mary and Bill. We have John saw Mary and heard Bill. And is connecting two verb phrases, the verb phrase saw Mary and the verb phrase heard Bill. In the next sentence, it connects two prepositions, the preposition to and the preposition from. John walked to and from the store. These are all things that English and can do very easily. But since we defined logical and as an operator that combines propositions, we can't analyze these sentences as shown here. We can't use logical and to connect the meaning of Mary, and I used that little prime on Mary to indicate that we're talking about the meaning of the word, not the word itself. It cannot connect the meaning of the word Mary and the meaning of the word Bill. It can't connect the meaning of the verb phrase saw Mary with the meaning of the verb phrase heard Bill. And it can't connect the meaning of to with the meaning of from. The asterisk, that kind of star at the beginning, is used to show that these are all ill-formed, things you can't do in logic. So we have an analysis, and it looks like it predicts, it makes a wrong prediction. It looks like it predicts that these things should all be bad in English, because if English and is logical and, then it shouldn't be able to connect two names, Mary and Bill. So how can we meet this challenge? Well, traditionally, what people have done to account for these without changing their analysis of and is what's called conjunction reduction. They assume that the actual structure of the sentences is a little bit different from what you hear. The sentence, John saw Mary and Bill, for example, would have an extra piece to it. John saw in the second conjunct that's not being pronounced, but it is being interpreted. And we indicate that with this crossing out. So the sentence is really, John saw Mary and Bill, except that you don't even whisper the John saw the second time. And we can do the same thing for John saw Mary and heard Bill. We can say that it has a silent occurrence of John in the second conjunct. And the to and from case is a little more complicated. It's got to have two different things crossed out. You cross out the store. It's there, just not pronounced. And you cross out John walked in the second conjunct, also there but not spoken. So if we have that as our underlying structures for the sentences, and we interpret the crossed out bits as well as the other parts, well then logical and can work. The sentence John saw Mary and Bill is interpreted as logical and conjoining the meaning of John saw Mary and the meaning of John saw Bill. And similarly for the other two examples. Okay, challenge number 2. Sometimes the English word and implies an order of events. In Japan, the sentence, John drank beer and he drove home, strongly suggests that John broke the law. The sentence, John drove home and he drank beer, on the other hand, suggests that John was being responsible. Logical and doesn't tell us anything about that. So why is it that these have these different implications? John drank beer and he drove home suggests that he drank beer first and he drove home afterwards. John drove home and he drank beer suggests the opposite order. Driving home was first, the drinking was second. But logical and just puts things together and tells you whether the result is true based on whether the pieces were true. It doesn't say anything about order. So the two analyses here, the two logical representations that are supposed to be the meanings of the sentences, are equivalent. The logical conjunction of John drank beer and he drove home is exactly identical to the logical conjunction of John drove home and he drank beer. Assuming, of course, that he is John in both cases. So what can we do to meet the challenge? Well, in this case, perhaps we can appeal to ordering outside of the semantics, but in the pragmatics. So when you speak, when you say two different sentences, we can't do those two at the same time. You have to say one first, and you have to say the other second. Okay, and that means you have to choose. You have to make a choice of which order to put them in. That ordering is something that we can use to convey information. For example, we could use it in the following way. We're going to say a sentence, one sentence before another to indicate that the event that the first sentence describes happens before the event that the second sentence describes. If something like that is part of our pragmatics, then our semantics can stay very simple. We can still use logical and as our semantic interpretation, and we use the pragmatics, the requirement of putting an order to things, to explain the ordering of events that we feel is there when we put the sentences in the order we put them. Okay, the third challenge is not going to be so easy to deal with. Some sentences with and do not allow conjunction reduction. Here are two examples. John, Mary, and Sue surrounded Bill. Say they held hands and Bill was in the middle. Or Mary, Sue, and Bill gathered in the park. The three of them together were there in the park. These are not the same as what you would get by a conjunction reduction. You can't take the first sentence and turn it into John surrounded Bill and Mary surrounded Bill and Sue surrounded Bill. You can't take the second one and turn it into Mary gathered in the park and Sue gathered in the park and Bill gathered in the park. Now the first one, the surrounding case, it does make sense. You can imagine people putting arms around another person, and you can maybe think of that as they're surrounding the person. It's a little bit of a stretch. But that's not what the original sentence is going to be taken to mean. The standard way of understanding that sentence is Bill here, John, Mary, Sue, and they form a circle around Bill. Okay, and in the second case, well, Mary gathered in the park, that's not even an acceptable thing to say. The word gather doesn't allow a single person to do it. So this is a case where it's very hard to see how to give an interpretation of and that conjoins propositions and still explains the meanings of these sentences. In fact, the challenge, as far as I know, cannot be met using logical and as the interpretation of English and. Some different interpretation of English and is needed. Now, we're going to continue using the logical and quite a lot in this textbook. We're going to also, we're going to use it for the interpretation of the word and, the English word and. And that is kind of like cheating. We know it's wrong. We know it doesn't work, and yet we're going to use it anyway. So why? So let me give you a few reasons why, and why it's not such a terribly bad thing to do. And keep in mind all the while that at some point we're going to have to do something more. At that point will have to be and not in this textbook, because the something more is going to go beyond what we can do for an introduction. Okay, so one reason we use ampersand, we use a logical and, is that it does work for one of the uses of and, where and connects two sentences, and it works very well for that. John left and Sue left. It seems like this interpretation gives us everything we need to know about in order to understand these kinds of sentences. A second answer is that it can also be used in cases of conjunction reduction. John and Sue left can be reduced to John left and Sue left. We have to go ahead and give an analysis of that. That's really part of the syntax, not the semantics. And that analysis has to work, but at least in principle, it's something that could be done, and it has a promise of working. The third answer is that logical and is a simple and obvious potential meaning for English and. And by using it, we can see how many uses of and can be captured by this simple meaning. We ended up getting actually pretty far with it. Now, this fourth answer is a reason for having logical and in our logic. It says nothing about using it to interpret and, but it's useful for interpreting other expressions. In the sentence, John is a nice man, for example, we can indicate part of what it means by saying it's a conjunction of John is a man and John is nice. And that and is the logical and. Now, you might argue that that's not the best interpretation for the sentence, but at least it's a proposal we can look at, and we know exactly what we mean when we put that proposal forth. And there are some cases where it actually gives us everything we need it to give us. And the fifth answer is that we understand the logic of logical and completely. It's given entirely by the truth table. There's nothing more to it. Very easy to understand. And so in any case where that is an acceptable interpretation of English and, then we get a complete understanding of that use of English and. Okay, so now what do we do with the other uses of and that can't be interpreted using the logical and? Well, here we're going to have to either define a separate operator that can handle those other cases, the surround case and the gather case, and we treat English and as ambiguous. It can sometimes mean logical and it can sometimes have this other meaning. Okay, or we can give a new operator that explains all of the occurrences of and. We're not going to do either in this book because, like I said, that would be far too complex for an introduction. So we're going to pretend that the answer is like the first answer. We will only be using instances of and that can be interpreted with logical and we'll push the other ones aside for a later day. Okay, let's turn to disjunction. And again, we'll start with a proposal. The proposal, the English word or is interpreted as logical disjunction, represented with this V-like symbol. Logical disjunction works like logical and. It combines two propositions, P and Q, into a new proposition, P or Q. And the meaning of logical or can be given completely by a truth table. Here is the truth table. If both P and Q are true, P or Q is true. This is a little bit of unintuitive aspect of this symbol, but we're defining the symbol, so it's not something that you can have intuitions about and think it's wrong. It might be the wrong interpretation for the English word or, but it is the way that the logic works. Okay. Second, if P is true and Q is false, then P or Q is true. If P is false and Q is true, P or Q is true. And if they're both false, then P or Q is false. So let's turn to challenges to analyzing OR as logical OR. The first one is just like the first challenge that we had with AND. Logical OR can only connect propositions, while English OR can connect other kinds of expressions. So just as we had with AND before, we have John saw Mary or John saw Bill, John saw Mary or Bill, John saw Mary or heard Bill, John walked to or from Tokyo. And we can meet the challenge in the exact same way using conjunction reduction. A second challenge, more particular to OR, is that sometimes the English OR is felt to be exclusive, meaning P or Q, but not both. So if I tell you John turned right or he went straight, I'm not trying to tell you that he might have done both. It seems like I'm trying to tell you he did one or the other, but not both. But logical OR is always interpreted as inclusive. The logical P or Q is true when both P and Q are true. So how can we meet this challenge? Well, in this case, it's not so terribly difficult. We can use world knowledge. In other cases, this might not be as easy, but in this case, world knowledge by itself eliminates the possibility of P and Q both being true. So if John is stopped at an intersection, he has choices. He can go left, he can go straight, he can go or he can go right. But he can't do more than one. Okay. Even if you think of the sentence as true, if he does two of them, he goes straight and right, there's no way for that to actually happen in the world. You can't go straight and right at the same time. Okay. So the only real situations that we have to worry about are situations where he does one. We can say that it's true in situations where he does both, but there are no situations like that, so we don't worry about them. Okay. The intuition that OR is exclusive is largely an intuition that the AND interpretation isn't an option. Well, this gives us a separate reason why it's not an option. The semantics can allow it, but we get rid of it using knowledge, our knowledge about the world. Okay, conditionals. Conditionals are weird. Okay, the analysis of conditionals that we're going to give is one that almost nobody likes when they first see it. Very few people like it when they second see it, and many people continue not to like it for a long time. But I'm going to give it, and I'm going to try to justify it at the same time. The proposal is this, that the English word if is interpreted as material implication in logic, represented with an arrow pointing to the right. And that logical if works like logical and logical or. It combines two propositions into a new proposition, and its meaning can be given by a truth table. So here, if P is true and Q is true, P arrow Q is true. If P is true and Q is false, P arrow Q is false. If P is false and Q is true, P arrow Q is true. And if both P and Q are false, P arrow Q is true. So before getting to the challenges, let me first look at a situation where this is a plausible way of understanding if. Consider the situation where a teacher gives students a hint on a multiple choice test. Here's the hint. If the answer to question 1 is A, the answer to question 2 is B. Now, if the actual answers are as given below, did the teacher tell the truth or a lie? Right? You've taken the test, you got it back, and you found out that the answer to 1 was A and the answer to 2 was B. That is, the if clause is a true sentence, and the second clause is a true sentence. What if the answer to the first one is A, but the answer to the second question is C? Then the first sentence was true, but the second sentence was false. What about in the other two situations? The answer to 1 was C and the answer to 2 was B. That is, the answer to the 1 isn't A, but the answer to 2 is B. Or in the case D, where the answer to 1 isn't A and the answer to 2 isn't B. Well, I think you'll agree that in these cases, what the teacher said would be the following. In case A, they would have said the truth. In case B, they would have lied, because that's exactly what the if is kind of ruling out. It's not possible for 1 to be A and 2 not to be B. That's what the if statement seems to be saying. But in the other two cases, the teacher gave you something that maybe was less than helpful. I don't know. But they didn't lie. They still spoke the truth in those cases. Okay, so this is a case where the analysis of if as logical arrow is plausible, possible. It seems to fit with our intuition. But the first challenge is this, that most of the time we take if to imply some kind of a connection between expressions. That connection can be a kind of a cause, or it can be some kind of an inference that we can draw between sentences. So for example, take the sentence, if it's raining, the streets are wet. This seems to imply that rain causes the streets to be wet. But arrow says nothing about cause. It only talks about truth. Or the sentence, if John's holding a wet umbrella, it's raining. John's holding a wet umbrella certainly doesn't cause rain. But if we know that he's holding a wet umbrella, that's a reason to believe that it's raining. So we make this connection, this inference. We infer, based on his holding an umbrella, that it's raining. That's our conclusion. Arrow says nothing about conclusions, says nothing about inferring one thing from another. Furthermore, when we're missing that kind of a connection, an if statement is kind of weird. If it's raining, 2 plus 2 equals 4. And you ask, what does 2 plus 2 equaling 4 have to do with the rain? Why do you ask that? Because we feel like there should be a connection if you're going to put them together with if, and there's no obvious connection. So it strikes us as weird. Okay, so let's see if we can meet this challenge without having to change our assumption about the meaning of if. I'm going to try to meet that challenge by looking at a speaker's justification. What you say, of course, usually if you're trying to be honest, you try to say something that's true. But you usually have many different ways of picking something that's true. And our choice depends then not only on whether we think it's true, but also on whether what it says about the situation matches our beliefs. Let me describe that in a little more detail. So suppose I know two things. I know that it's raining. I looked out and I saw. I know that the streets are wet. I looked at the streets and I saw that too, okay? And I want to tell you what I know. I want to tell you something. I want to be informative so you can make a proper decision about what shoes to wear, about whether to bring an umbrella, etc. Okay? I could say it's raining and the streets are wet. I could say it's raining or the streets are wet. I could say if it's raining, the streets are wet. I could say it's raining and the streets are wet, or it's not raining. All of these would be true things to say, but it's very clear which one is the best. The first one, and. Why? Well, let's look at the truth tables and see. The truth table for and, here. Can't do that. For and, in this column, tells us that it's true in a situation where both P and Q are true. In this case, when it's both raining and and the streets are wet. But if you look at situation A, like I said before, everything is true in that situation. All of the statements that we are trying to choose between, they're all true in that situation. And that is the situation that we're in. So, okay, no difference. But if you look at the other situations, in situation B, that's where, and I can't highlight it, that's where it's raining outside, but the streets are not wet. Well, then the sentence, it's raining and the streets are wet, is false. If we're in situation C, where it's not raining outside, but the streets are wet, again, it's the and sentence is false. And where it's not raining and the streets are dry, again, it's raining and the streets are wet, is false. So this expression, P and Q, adequately describes the situation we're in and also gives you an expectation that we're not in any of the other situations. None of the other expressions do that. P or Q, we said, is true in the situation where P and Q are both true. So we're accepting that it's raining or the streets are wet is true when it's raining and the streets are wet, okay? But it's also true in these other two circumstances, where it's raining but the streets are somehow dry, or where it's not raining but the streets are wet. And so if we choose this, we will not convey the information that we are in an A-like situation. We'll convey the information that we're in one of these three, A, B, or C-like situations. And that's not as helpful. If we want to be most helpful, we're going to pick something that does better than that. We're going to pick P and Q. The same thing is going to happen with P arrow Q. If we were to choose, we would choose this if we knew we might be in A, we might be in C, we might be in D, but we're not in B. But that's not the situation we were in. We were in a situation where we know we're in situation A. So this is not the best thing to say. Okay. Of all of these, the only one that matches what we know about the situation, we know we're in an A-like situation, the only one that matches that exactly is P and Q. Okay. So we're going to take this as a new basis for a new hypothesis, a new theory, if you will. The theory is this: when you have a choice of many ways of describing the situation, you choose the one that fits best what you believe about that situation. Now, by this reasoning, to use a statement meaning P arrow Q, I have to know that I'm in a situation that's like A, C, or D, and that I'm not in a situation like B. B was where it's raining and the streets are not wet. However, I must also not be able to eliminate, get rid of any of A, C, or D as situations I might be in. Because if I could eliminate any of them, there's going to be some other formula that would be a better match for what I know. So how can I be in this state of mind? Well, the most common way is by knowing that Q follows from P. Maybe by a cause, maybe by inference, but that knowing P is enough to infer Q. Okay, now this isn't yet a full explanation, but it gives us the basis of a possible explanation. And if it's possible to give an explanation for where that extra connection between sentences comes from, then the arrow might still be an acceptable semantic meaning for if. Now, this isn't perhaps the standard explanation that you will find in other places, but the approach is very similar to what you will find elsewhere. It's trying to look for pragmatic reasons why an if-then statement would give you more than just a comment about truth. Okay, we have a second challenge, which is this. An if statement is usually inappropriate when the antecedent is known to be false, at least the if statements we're looking at. So suppose you're inside with me, and you know you're inside, I know we're inside. There's no doubt about that. It's raining outside. Can I say, if you're outside right now, you'll get wet? Seems a very strange thing to say. I know you're not outside, so why am I saying if you are outside? You know you're not outside. Why am I saying if you are outside? Okay, I know that's false. Well, what we've said about matching meanings and beliefs could give us an explanation now about why this is a strange thing to say. Knowing that you are outside now is false means knowing that P is false in the formula P arrow Q, that's supposed to be a translation of if you are outside now, you will get wet. This means that knowing the situation is like, this means that we know the situation is like C or D and not like A or B. If we want to communicate what we know, then we should pick out a way that matches what we know. We should say something true in situations C and D, but false in situations A and B. But P arrow Q doesn't match in this way. So it's expected to not be the appropriate thing to say. Okay, the last expression to look at is negation. And we're going to make the following proposal, that the English word not is analyzed as logical negation, represented with this squiggly line. Now, logical negation differs from the logical and, or, and arrow in that it only combines with one proposition, not two. But like the others, its meaning can be described in a truth table. Not P has the opposite truth value as P. If P is true, not P is false. If P is false, not P is true. So, challenges. What challenges do we have for analyzing English not as logical not? Well, the first one is that logical not always combines with a proposition, but English not usually combines with a predicate expression, not with a sentence. We say, John did not come. We don't say, not John came, or not John did come. We don't put the not at the end of the sentence so it can combine with the rest as a sentence. We combine it somehow with something in the middle. And this is a challenge that can be met, but it's going to take us another few weeks to be able to meet it. And so I'm going to wait. I'm going to put this off. We're going to do this later. In chapter 4, we'll see how to combine not in John did not come, first with come, then with did, and finally with John, to generate a meaning which is exactly equal to the logical negation combined with the meaning of the sentence, John did come. We don't have the tools for doing that yet, and so I'm going to have to ask you to just trust me for now. Believe that this isn't a real problem. It's a problem that can be met. The second challenge is that not is used sometimes to indicate that something is not appropriate rather than not true. But logical negation only shows that the proposition it attaches to is not true. So here's an example. I tell you, John didn't kick the bucket, he passed away. The expression kick the bucket means the same thing as the expression pass away. They're both indirect ways of saying die. If we understood this as just a normal use of not, applying to the normal interpretations of the sentences, this should mean John didn't die, he died. And that is a clear contradiction. But that's not the way we understand it. The way we understand it is more like John kicked the bucket is not the appropriate thing to say. John passed away, that's the appropriate thing to say. Okay? So how can we meet this challenge without having to give up our interpretation of not? Well, perhaps we can look at the utterances themselves independently of not and see and take them to sometimes express appropriateness. We can give other examples that don't contain the word not at all. For example, John kicked the bucket. In contrast, Mary passed away. The only thing that's contrasting here is the way that you're describing the situation. Is it kick the bucket or is it pass away? They're both describing the same thing. If you use the same words, it wouldn't work as a contrast. John died. In contrast, Mary died. That's not a contrast. So we have other cases where it seems that the way we say something matters, and we can pick up on that with words like in contrast. It says that it's the appropriate way to say John died is John kicked the bucket, and the appropriate way to say Mary died is Mary passed away. Why that's the appropriate way, we leave that to whoever's talking. Okay? But then we might be able to analyze the sentence, John didn't kick the bucket, as negation, logical negation, attached to the interpretation of the sentence. The appropriate way to say John died is John kicked the bucket. And in this analysis, not is analyzed as logical negation as elsewhere. Okay. So we had what looked like a challenge, but we found a way of meeting that challenge without giving up on our analysis. That, of course, doesn't mean the analysis is right. In 3 cases, we ended up facing all 3 challenges and having at least an approach for how to save the proposal against the challenges. In the 4th case with and, well, we came up with something in the end that showed that our analysis is wrong. But the important point, I guess, for this chapter is 2 things. One, that we're using logic to give very precise meanings that give us very clear predictions about what a sentence can and cannot mean. And then we're conducting semantics as a science. We're trying to analyze words of English, and, or, if, and not, and we're using the logic to give us those analyses. And then we go back to looking at English to test. So we made observations about entailments, about truth in situations involving sentences with and, or, not, if. We gave a theory. These were our proposals at the beginning. It was also the definitions of entailment. These theories gave us predictions about when entailment should hold, when something should be true or false, how the truth of one sentence should relate to the truth of another sentence. And then we tried to test those. We tested them by trying to show that the predictions are wrong, showing things where it's not obvious why or how the analysis can explain the observations. Sometimes we could stick to the analysis, sometimes we couldn't. But that is how you do semantics as science.